This video is concerned with critical path analysis. Now, what we're doing here is we're looking for the longest path, which determines the earliest project finish time. Projects may go through various stages, and each stage will require some time to complete. And what critical path analysis does is it looks at all of these different possibilities, these routes, and tries to determine the best one, or what is the critical one and what slack is involved in the system. So we're going to look at the longest path, which determines the earliest project finish time. Now, the longest path time is called the critical path. It's critical because there's no slippage possible. It's the longest time that's possible to be allocated for the completion of the task or completion of the job. So there is no slippage. It must be completed within that time frame. And we'll see how this works when we have a diagram shortly. Tasks on the critical path, not surprisingly, are called critical tasks. And non-critical tasks have float or slack involved in their completion. So non-critical tasks will have some element of slack built in. And again, we'll see how that works when we look at the diagram. In fact, let's look at a network diagram. So here's a simple, straightforward one. It's 4 activities, A, B, C, and D. And you'll see from the diagram that B and C must be completed after A has been completed. And D follows on from B and C. So in fact we have 2 routes. I'll just put the cursor onto the screen. We could go up and across, or could come down and across. So once we leave A, we could go to B, to C, so we could go A, C, D, or we could go A, B, D. We have a choice here. We have which way to move. And this is what critical path analysis does, essentially. It selects which route to take. Now, if we add in a little detail here, if we take the top path, A, B, D, we'd have 2 weeks to complete A, 3 weeks to complete B, and 4 weeks to complete D. So it's 2 plus 3 plus 4, 9 weeks. So if we go on the top one, it'll take 9 weeks. If you come on the bottom one, it's 2 weeks plus 2 weeks plus 4 weeks. So it's 2 plus 2 plus 4, which is 8 weeks. In this case, we have 1 week of slack, or 1 week of float. And that's caused by this non-critical task. Non-critical. This one must be completed. It's essential that this one is completed because this is the critical path. This one down here has slack built in. So it's not critical. There is 1 week of slack in the system. So it's not that critical. We could use a Gantt chart to represent this. We could say, well, here's project A, or sorry, I beg your pardon, task A, 2 weeks, task B, 3 weeks, task C, 2 weeks, and we have a float here because B takes up 3 weeks. This is our critical path, A, B, D, and you can see if we've gone A, C, D, we have this float. We have a week of slack in which this one can be completed. So we could do it using a Gantt chart. Now, let's go back and start to work out how these things are calculated. First of all, we note here something called a forward pass. We move from the left to the right. It's the direction of the arrows. So we have a forward pass. And the forward pass calculates the earliest finish date. So let's insert some numbers and see how it works. So we start with 0, that's when the project starts at the beginning. 2 weeks, 2 weeks there. So B and C can't start until A has been completed. So we have 2 weeks and 2 weeks. So they can start at that point once A has been completed. And if we add the 3 to the 2, we get 5. So this one here will be ready in 5 weeks. And this one here will be ready in 4 weeks. We just simply add on. Now, D, we carry down to 5. Now, let's look at this for a second. We have 2, B and C, 2 of them going into 1. So 2 feeding into 1. And we have 2 feeding into 1, 2 or more feeding into 1. We always take the largest number. Over here we have 1 feeding into 2. 1 goes to B, 1 goes to, and A goes to C. A, B, A, C. So we carry over the 2. Over here we have a difference between the 5 and the 4. And our rule tells us to take the largest number. So when we have 2 feeding into 1, we take the largest number. It's important to remember that. Now, we have a forward pass, so we can have a backward pass as well. So the forward pass calculates the earliest finish date. The backward pass calculates the critical path and the slack of non-critical tasks. So we calculate backwards as well. Now, let's have a think about this again. Here we have 1 task feeding into 2. So we carry forward the 2. 1 task feeding into 2, we carry forward the 2. Down here we have 2 tasks feeding into 1. In this case we always carry forward the largest number. So the earliest finish time will be 9. We have the 5 plus 4, which is 9. So when we have 2 feeding into 1, we carry forward the largest number. When we have 1 feeding into 2, we carry forward that number. If we had just 1 feeding into 1, we just simply carry forward the number. 4 goes to 4. So here we have the highest number, which is the latest date, and the earliest finish date, which is 9. So we always carry forward the largest number. Now let's calculate the backward pass. Well, we do this by taking down the 9s here and subtracting the 4. So we're moving backwards. I know the arrows here are pointing to the right. That arrow there is pointing to the right. We're just really interested in the connections here. Don't worry about the direction of the arrow. We're interested in the connections. This one is connected to 2, so we'll just take it as connected. Don't worry about the direction of the arrows. Anyway, so now we've got a 9, carry it down, 9, subtract the 4, which gives us a 5. Carry the 5 back, it goes back to 2, so we go back 5 and 5. Now, here on this top one we've got 3, so subtract the 3 from the 5, which gives us a 2. Down here we subtract the 2 from the 5, giving us a 3. So our choice now is between 2 and 3. And as it says here, carry back the smallest number. So always take the smallest number going back. So we have the 2, 3, and this 3 here links to this one. So it's 2, so take the smallest number going back. And we've now got this number 2, and that completes our route. So the critical path is the one without slack. So the critical path will be A, B, D. There's what we've got. We've got the earliest start time here, the latest start time, earliest and the latest. The earliest finish time and the latest finish time. Now if these numbers are the same, we have no slack. So if the earliest and latest start times are the same, then the difference would be 0. This is the critical task. This task here is critical. In fact, this path is the critical path. A, B, D. This one down here has got slack. There's a difference in the numbers. 4 and a 5, a 2 and a 3. If there's a difference in the numbers, there is slack. So we have the earliest finish time and the latest finish time, and they're the same. And that indicates it's critical. Now let's look at an example. And the example won't take an easy one, we'll take a fairly complex one. But let's look at an example of how this works. Now, don't get put off by the amount of calculation. It's very, very straightforward. Just a question of remembering our rules. Carrying forward the largest one on the top and the smallest one on the bottom. Right, so we have a task here. A, B, D, E, G, H, F and C. And these are all connected, so these tasks must be completed in this direction. So B here could go to D, which goes down to G, or in fact it could go simply B, G. And D can go G and H. Let's just take some across here and see how it works. Well, first of all, take this 2. Well, the 2 goes, it's 1 into 2, 1 to many. Many here is 2. So this 2 comes down here and the 2 goes up there. So it's because it's 1 to many, 1 to 2. Actually, the 2, there's a third one here which goes across, and the 2 doesn't seem to appear over here. And there's a good reason for that, which I'll explain in a second. Now, let's go just the top one for a second. So we've got 2 plus 5, it's 7. So we carry the 7 across, and that could come down here. That 7 can come down here, but it doesn't appear down here either. There's a 12 there. Like this 2 plus 3 is 5. That gives us that 5. And the 5 goes there. 5 and 7 is 12. So this 12 can go over there or it can go up here. So we always take the largest number, so we take 12. And that's why we don't have that 7 coming down. And we don't have this 11. 7 and 4 is 11. We don't have 11 coming down, we have 12. And the reason we got 12 is because of this lot here. We have a 12 here, so the 12 goes up there. So this 9 we got to. Here we take up the 5. 5 and 4 is 9. That 9 is not used either, because we always look for the biggest number, and the biggest number, as I said, is coming from down here. So we take the 12 forward. 12 and 3 is 15. 15 goes across here. Well, we could have taken an 11. Well, 15 is bigger than the 11, so that doesn't work. The 11 could come down here as well, but we've taken a 12. Always take the largest number, so we've taken 12 here. Over here, we've got 15. We could have, the 11 doesn't work because the 11 is there, so we're not going to use it. So 15 plus 5 is 20. Right. Now, let's just now work out the backward movements to see if we can make any sense of those. That's our table so far. That's what we've got to. Now, let's go backwards. We start with the 20. Let's say this 20 here. We'll take the 20 down. So that's our starting point. So here we start on the right because we're working backwards. We're working to the left. So we start on the right. That's 20 and 20. Take away 5, 15, 15. Right, so we've now got 15 here. So we carry that 15 across to here. There's one going in there. And there's a 15 here that's going in that direction. We're not taking it. We'll notice here it's a 12 here. We're not taking that 15 because 15 minus 3 is 12. We always take the smallest number, so we're going to take the 12 here, not the 15. So we're taking that 12, take away the 4, which gives us 8. Now, this 8 can go back here because that's a connection, so we can take the 8 back there. Take away 5, which gives us 3. Okay, so that's where we've got to. We've got a 3 here. You can see we've got a 2 down here, so there's obviously a better route than this one. This one is telling us 3, this one's telling us 2. So we need to go back and find where this 2 crops up. Well, if we look at this one here, we've now got 15. Well, there's a 12 feeding in here as well. So we take the 12. Always take the smallest number going backwards. So 12, this 12, can go here. We're not going to take the 15 because it's too big. Sorry. 15 is too big. So 12 minus 7 is 5. Now, 5 comes back here because there's only one connection here between F and C. So that 5 goes straight back. Take away the 3, which is a 2, and we can take that 2 upwards. Now we take that because the 3 is no good here. Likewise, if we'd worked our way across here, we'd find an 8. Well, 2 is better than the 8. 2 is smaller than the 8. Let's just work this one across just to see where we got to here, by the way. We had 15 here, and take the 15, take away the 3, which is a 12. Let's say we have this 12 here, which would be this one here coming across, because there's one connection here between the two of those, so we take that 12 across. E and G are just linked by one connection, so it's whatever this one is, this one must be the same. Take away 4, which gives us 8. Now, there are two connections between C, one going to E and one going to F. Take the smallest one, so we have an 8 here and a 5 here. So we always take the smallest, take the 5. Subtract the 3 gives us a 2. And that's how we got the 2 up here. Okay. Now, if you look over here, here we've got a 9 and 12. So there's a gap there. They're not the same, so it's not critical. In fact, the gap is 3. 5 and 8. Gap is 3. Over here, the gap is 1. 11 and 12. 7 and 8. Gap is 1. Here, the gap is 1. So if we go this route, we have slack of 1. Go down here, we have slack of 3. So the critical root is A, C, F, and that F goes into there, to the 12, 3 is 15, 15 across. So the critical root is A, C, F, G, H. This is a non-critical root here. We can't have this one, and we can't have those two up there. Now I appreciate that the numbers here look a bit confusing, but once you remember to take the largest one forward going across the top, always take the largest, and take the smallest coming back, you can't really go wrong. The diagram I've given here is somewhat complex. We've got lots going on here. We have multiples going into 1, we have singles going into 1, and so on. So I made it complex just to show you how to calculate a more complicated problem. But it is a good technique. In large organizations, this computation will be done by computers, as you would expect. But it's important to know how to do it by hand and understand what the technique is trying to tell us. And that's essentially all there is to know. Top ones take the largest, bottom ones take the smallest. When there's a gap between them, it's non-critical. When there's no gap here, 5, 5, 5, 5, 12, 12, 15, 15, 20, 20. So on this one, this is the critical path. So we go 2, C, F, G, H. That's all we really need to do on the calculation of critical path. Practice it, look at the numbers, and remember the two rules. Largest on the top, smallest coming back on the left. The backward move, smallest. The forward move, largest. And that completes this little talk, so thank you for watching.